Just testing out the jump, I noticed that sometimes it doesn't seem like it's starting the animation quite right when he lands on something, like it's still trying to finish the jump animation. So when you jump right away, he comes off the ground, but it's still trying to finish the last animation. So to test that, I'm setting his jump velocity at 65% of what it was. You can see when he jumps up now, sometimes he doesn't, he does jump up in the air again, but you can see it's still trying to finish the previous animation. So a quick and easy fix, I just put in a comment up here, I'll just uncomment it, is in the jump animation, we'll just tell it that the last hero animation was actually idle. So we'll trick it. That way when it comes down to set animation in here, it'll restart that animation. So now you can see he's jumping off the way he should. His feet are always moving when you push stop button or spacebar. So I'm just going to bring down his max jump just a little bit because it seems a little extreme. There, that's a little better. Might even want to bring it down a little bit more. And then if he gets a special power up, or we could even have him charge his jumps, so he starts ducking, and then he hit the jump button, he'll go flying up. To clarify the code here, I added some comments. Don't re-trigger jump that's already started. If the jump is pressed, then continue. If on the ground or spikes, continue. Cause set animation to reset jump animation. When this will make a mismatch between the animations by setting it to idle. So when set animation is triggered and it sees that they don't match and it's now set to motion.jump, it'll restart that animation. Just to test out that jump boosting idea, I probably won't have this in the release code, but just as an experiment and to show you, I added this global jump boost set at 0 so that when we're in duck mode we can charge up a jump and jump a little higher. So we'll set jump boost to -2 when down is pressed. If we're going to use a jump boost to make him fly up, when it does the check input, we want to make sure to set jump boost back to 0 if it returns because they weren't pressing the up button or the jump button while ducking, and also reset it back to 0 if he's not on the ground. And the reason for this is you might press the down button to charge your jump and then let go of it and then go do other things, and then when you go to jump, the jump boost is still turned on and you don't want that. So when he ducks down, by default it would set jump boost to -2 to go up an extra 2 in velocity, and then this would return it to 0 if it doesn't count. Same thing for standing up or ducking down. So this could actually be taken out of here and put down here instead if you want. That way you don't have to repeat it. Then in this part here where you're leaving the ground for your jump, because your key 1 is no longer part of the anticipation animation and you're in the start state and transitioning to air state, then you can add that jump boost and then reset the boost back to 0. So his velocity will immediately be set to a higher jump speed and gravity will take care of the rest. And then for example, if you wanted to indicate that he's charging a jump, this is just a rough example. This isn't how I would do it, but I added a counter in here and I'm saying if the remainder divided by 2 is less than 1, which is going to happen for every second time, and if he's ducking, then I set the blend state to additive instead of alpha blend, so he kind of flashes a little bit to show that he's charging up his jump. So kind of like that. We might want to use a different modulus, like we might want to say 4 less than 2, something like that. That way the flashing is more obvious. And then when you hit jump, he jumps higher. So this would be normal jump. And then you hit down and hit the button to go a little higher. However, I want to keep the source code simple, less confusing, and make it easy for a beginner to navigate the level. Right now at that jump velocity he can't reach this example map, so I'll set everything to a simpler version for the source code release. So I'll set the max velocity for the jump back to -13. -14 is a bit too much. -13 he can still reach all the platforms. I'll show you a neat trick. Notice he slides when he hits that tile. What we can do is go to our motion.jump case, and what I've done is I've added this here so that if he's in air mode or at the end of a jump, as long as it's not the start of the animation for the jump and he is grounded, so he's just started touching the ground and his velocity is not 0, If it's 0, it's not going to matter. Then we're going to set his animation to walk. Now it may have set it to walk and he's just starting to jump again. So we're going to put this else here, hero motion dot jump, so it can go from walk back to jump. That way we don't mess it up. So now as soon as he touches the ground, he starts walking. Yeah, you can't get him to slide anymore. He'll just walk right away. Just as sort of a tip, I'm not going to do this in this tutorial, but later on, you can do something like this, where it replaces all this stuff here with just if collide up, x comma y minus 1, stop y, and then you can do x plus 1, y minus 1, and ahead of time you would provide these offsets, like the horizontal offset for a plus 1, or you could even do collide up minus 1, and if collide up r, that'd be to the right. What you could even do is you could say collide.set x comma y, and then have a bunch of commands like this. And if you want to check the tile above it, you'd say top, upright, or whatever. So there's lots of different ways you could do it. And then you could share that class with the monster class or any other actors, and they just set their parameters for where the top of the character is, the bottom of the character, adjustments, stuff like that. You'd have to work out specifically how you'd want to do it, but for this tutorial we're just going to keep it the way it is, so we don't have to spend too much time. For a big project though, something like that might actually save you time in the long run. And before I had this hit spike section out here, you actually want it inside the move.y greater than 0, so I moved it into here. If we're on the spikes, and well, we know move y dot y would be greater than 0 because we're in here obviously, so say velocity.y is equal to -6f, and we'll call a hero damage we'll have to make, and how much damage you should receive. 0.2 for spikes. For now, let's just see if that affects our velocity. Yep, it does. We just got to make sure it plays the animation for that too. To do that, let's add this hero damaged thing. We'll go up, and somewhere between hero jump and update, we'll add hero damaged, public void hero damage, and life loss. If we're already invincible, meaning we just got hit, or if we are invincible for some other reason, then we'll return. Just can't take damage when you're invincible. We'll make sure to set the animation, and we can do that safely because it won't set it unless you're not invincible, and if you did get damaged then you'd be invincible for a little while. So say ouch index and the direction. So I'm directly setting the animation here, and we'll say must finish animation is true so that the user definitely knows that they received damage. They can see the character's reaction. If the motion of the character is duck, then we'll reduce how much life you actually lose, because he's kind of in an armadillo state when he's ducking. You can do that however you want. And we'll set invincible to be 100. We need a life bar to indicate how much life he's lost. Let's go down to our draw so that we can show him flashing so you know that he's invincible. So if invincible is greater than 0, we'll say n is equal to invincible modulus 10, and then if n is greater than 5, for 5 cycles it'll be on, for 5 cycles it'll be off. That's kind of how that works. And he should flash sort of a reddish tint. And you can jump when you're hurt, so it's possible to get out of the spikes. And if you don't want him bouncing up each time he touches them while he's invincible, you can say if invincible is greater than 0. Although I kind of like him bouncing up, so I might just leave it that way. Oh, this should actually be equal to 0, less than or equal to. And maybe we'll leave it that way. So next, let's add a life bar. We'll need a heads-up display that'll show the status of the character. Let's go to the user interface over here, the user interface folder, and right-click, add a class. I'll just call it HUD for short. So our constructor will take sprite batch and sprite font. And let's make sure we set the references for those in here. Resolve okay in sprite font. And it'll need a texture that we'll use for drawing, HUD text, and some rectangles for regions on that, like life bar border. Life bar will be inside it, inside the border, so that part will change. And probably a fancy graphic instead of just using the regular font for the word life. That'll be beside the life bar or beside the character's lives. Actually, beside the character's lives, we'll put a little mini version of the hero so you can see that's how many lives you have, and an adapting life bar rectangle that changes in size. So this will be the initial life bar. And we'll want a position for our life bar, so position, lives position, life word position, and the number position for the lives. We'll call it count position, and we'll keep track of how much life the character has and how many lives. So not a whole lot of status information for this example, not exactly an RPG yet, so we'll just say sprite batch equals SPR, font equals font. Let's go make a graphic that has all these elements in it. I chose an image size of 512, 512, giving myself some extra room to add other features for the heads-up display. So this is our regular life bar rec, full-size version. We're going to adjust this rec depending on how much life the character has. So the source rec will be extrapolated from this rectangle. This is our life font, and we'll have a rectangle around that. We can use something like info to extract the coordinates, so we can see this is 284 wide, 21 down. If you drag this out, it says 284 and 21. So that's your width and height. And you can extract the coordinates using this here to show the top left-hand corner of where you want to grab it from and all that stuff. So save this as a PNG into the content folder, and just make sure to open up your content monogame pipeline and go edit, add, existing, because I already put it in the folder, add link, build, and save. Alright, so we can start adding our source rectangles based on the information I wrote down. So life bar border is a rectangle that starts at 0 and 64, 284 wide, and 21 vertically. So this is 64 down, and this will fit around this thing. The life bar is 0, 0, 284, 21, life word, 0, 22, 60, 27. Mini hero, 326, 14, 48, 37. Life word position will be set to new vector to 10 horizontally, 6 vertically. And we'll set the life bar position. This will be over to the right from that, say 70 and 10 down. Lives position, 60 and 3. Count position, new vector 2 for 10 and 10. And to load it, need the content manager. So now we can say heads up display texture containing all our little images. Load as a texture 2D. HUD because it's HUD.png. Initially life is 1, which is 100%, and lives, we'll say starts off with 2, and the initial life rectangle is going to be equal to life bar. Oh, and let's resolve this. If we're drawing it, draw, we'll say void draw sprite batch draw using HUD text. Life word, there'll be the life in the top left hand corner, life word, to show that that is indeed a life bar. Full color, and at lives position, draw the mini hero, and we'll draw a string beside it. Lives, count position, so it'll put times plus the string version of whatever lives is. Use lime green, because for some reason I like using that with fonts. And we'll say the life width, or the rectangle width for life, cast integer, cast a float first for the life bar width, life bar.width times life, which is a float that ranges 0 to 1. And then we'll draw at the life bar position, the life rect, now you can see how much life he has. And also at the life bar position, let's draw the life bar border over top. I think that's all we need for heads up display, so let's go back to player. Actually, no, let's go to game 1 first, because probably monster class and other actors will want access to the heads up display so they can draw status for those other things. So we'll put HUD in here. Actually, first go back into the HUD class and just change the namespace to platformer so we don't have to say using. So this will be our heads up display section. I don't know if there's any other display type objects we're going to put in here, but let's leave it like that for now. We'll go down to load content and we'll load heads up display in here. First we'll create it, we'll give it access to sprite batch and the font which we just made. And we can say heads up display.load and pass in the content manager so it can load the texture. And let's pass it into the player, and we just gotta add explosions and check for game state changes. Let's have it react to how many lives we have. If that's less than 0, then we can change the game state to game over, which we made something to handle that already. And moving down into draw, after we've done our additive effects, we'll put our interface and instructions over top, so any text or HUD. Since we're in play mode, we can draw the heads up display here. Just keep in mind though, if you got multiple actors, you're going to want your heads-up display to belong to each actor individually and draw it from within your player class or actor class. So at the top of the player class, under state section, let's add reference to the HUD. And we can head down to the constructor of the player, and we'll just say HUD, go down under input and say HUD is equal to HD. Okay, so now in hero damaged, we can add HUD.life minus equals life loss. And we can say if HUD.life less than equal to 0, we'll make explosion and sound effects. Let's say HUD.life equals 1 to refill the life bar, but HUD.lives minus minus, because you just lost a life. And then we got to send his location on the map to starting location, or whatever the last checkpoint is, depending on how you're doing it. Start data.apply, and then we got to set his player position tile to world using that location plus our vector offset that we're using. Well, hopefully this works. Let's try it out. Okay, got a full life bar. Oh, he's losing life. Yep, yeah, so he loses 20% of his life every time he gets hit, and then he just lost his life, so he started off back here. And if I do this enough times, it should go game over. Game over. It's not centered too well. I'll have to fix that.